Welcome back to FuzeTox channel. In this video I try to explain how browsers work, and it's a first part of how browsers works, and this part describes how browsers parsing HTML. So let's take a site. As a web developer, learning the internals of browser operations helps you make better decisions and know the justification behind development best practices. Yeah, it's true. So browsers is a hard and huge machine of engines and parsers, which allows us to go to the link, open new sites, new web pages, search the World Wide Web, and get happy of it. So the next slide. So we have now major browsers on desktop. It's a Chrome, Internet Explorer, Firefox, Safari, and Opera. On the mobile, it's Android browser, iPhone browser, Opera Mini and Opera Mobile, PC browser, the Nokia S4, S60 browsers, and Chrome. So the browser main functionality, which is common for all browsers, is presents the web resources which you choose. By requesting it from the server and displaying it in the browser window. So our resource is HTML, and its location encoded by a URI, Uniform Resource Identifier. Example of URI is URL. So browser high-level structure consists of UI user interface, BE browser engine, RE rendering engine, networking, UI backend, JS interpreter, and data storage. So we have an image which describes how these elements connected to each other. So we have a user interface, which we see when we try to make something on the web page. Inside of it, we have a browser engine, which can go to data persistence. And inside the browser engine, they have a rendering engine, which have three parts. It's networking, JavaScript interpreter, and UI backend. So let's start from the rendering engine. The rendering engine can display HTML and XML documents and images. It can display other types of data via plugins or extensions. So rendering engines, in modern world, we have a lot of rendering engines for many browsers. For example, Internet Explorer uses Trident. It was before Internet Explorer moved to Chromium project. It's for IE less than 11, IE 10, IE 9, and lower. So Firefox uses Gecko, Safari uses WebKit, and Chrome and Opera from version 15 use Blink. It's a fork of WebKit. WebKit is a fork of KHTML, if you know. So the next page is the main flow. So the main flow consists of parsing HTML to construct the DOM tree, render tree construction, and layout of the render tree. After all, it should be painting the render tree. So let's go into WebKit engine. So WebKit do many things. First, start from HTML, and in parallel with style sheets, HTML parses with HTML parser. CSS style sheets starts with CSS parser. After all, it should be connected with DOM. It creates DOM tree. CSS styles applies to DOM tree, the attachment. After this attachment, it created a render tree, which creates layout. And after all, it painting. It is not displaying. It's just create layers for our presentation, and after all, it should be displayed to our users. So in Gecko, we have a similar steps. So it also starts in parallel with HTML and CSS style sheets with their parsers. for HTML, HTML parsers, for CSS, CSS style sheet parsers. So it's a content sync. Goes to the content model, CSS parser goes to CSS row. In this part, in this level, they create a DOM. It named a frame constructor. And this in WebKit, it's same as attachment. After all, it's create frame tree. In WebKit, it's a render tree. Reflow is layout. Is our layout, and painting goes to display. So WebKit used two well-known parser generators, Flex for creating and Elixir and Bison for creating Elixir and Bison for creating parser. So Flex input is a file containing regular expression definitions of the tokens. Bison's input is language syntax rules in BNF format. It's a common format, Backosnaur form. It's a widespread form. Also, this form, augmented Backosnaur form, is used in zero hours. So we have an HTML parser which parses HTML, and let's go into it. The HTML grammar definition is firstly created by World Wide Web Committee. In short, it's W3C. So it's a context-free grammar. So we have HTML DTD. HTML is a part of SGML family current string DTD. So we have a simple HTML DOM structure, which consists of HTML tag, body tag, some e tag with hello world, and div with image. So also we have it will create DOM elements. For HTML, it will be HTML element. For body, HTML body element. We have two tags P for HTML paragraph element, HTML div element, and inside HTML paragraph element we have a text node. Text node in the DOM document object model, where it's a text is also part of DOM node, like HTML image element. DOM technical reports HTML definitions. We have a documentation by this link. So we have two steps of HTML parsing. The first step is tokenization, and the second is pre-construction. It's very simple. So it starts. It's an image from what we do. We have this link, multi-page parsing HTML. So it starts from network. We have to accept by string decoder. After all, we have to input string preprocessor, which go to tokenizer. After all, tree construction and iterative script execution, yes. And if we have document write, it can change input string preprocessor. After all, tokenizer. After that, tree construction, and creates DOM. And when we make something on our web page, it also go to script execution, change input string preprocessor, change tokenizer, change tree construction, and change DOM. So the tokenization algorithm is expressed as a state machine. Each state consumes one or more characters of the input string and updates the next state according to those characters. The decision is influenced by the current tokenization state and by the tree construction state. So we have states of the states machine: data, tag open, calls tag open state, tag name, and we start from this. It's EOF, it's end of file. We have to consume as the emit character token, and if tag open, we should consume this, create a new and tag open, calls tag open state, consume as tag name. It's a steps. So when we go to from start to end, we should it works as a stack machine. If our tag is open, it should be closed, and if we have a lot of open tags, we should, after all, it should be closed. So we have to consume as the create new start tag token, and after all, it can be go to the data, and when our file go to the end, it exit of this tokenization process. So after this, we have tree construction algorithm. Each node will be processed by the tree structure. The specification defines the relevant DOM element for each token, which will be created as element is added to the DOM tree, and also the stack of open elements. This stack is used to correct nesting mismatches and unclosed text. The algorithm is also described as a state machine. States are called insertion nodes. So it works as described below. So we have an initial node, an HTML token reprocessed HTML token. We have before HTML, before head, in head, in body, after body, after body, and after all, we go to the end of file token. So actions when the parsing is finished. At this stage, the browser will mark the document as interactive and start parsing scripts that are in the deferred mode, those that should be executed after the document is parsed. Document state will be then set to complete and a load event will be fired. So we have a full documentation about HTML parsing. So I should say that browser zero tolerance, something about, so our browser is too smart, and when they try to open broken HTML, broken CSS, it try to fix it. And browsers have a huge tolerance, maybe because first sites were written with mistakes. And because of that, browsers try to fix it, and they try to fix it so we can just put HTML document with one p tag, and when we try to open this in our browser added HTML body tag, head tag to make a right structure of this document and display it to user. Thanks for watching. Bye.